Welcome back to the geometry unit. Today we're going to be talking about similar figures again. However, we're going to go back and reach to our old friend proportions to help us solve and figure out missing sides of similar figures. Let's go ahead and take a look at some key ideas. So some key ideas that we have to know before we start using proportions with similar figures is we need to set up a proportion using the lengths of the corresponding sides. And we're going to see what that looks like later. Then we're going to find cross products, and if those cross products are equal, the polygons are going to be similar. And again, we're going to see what that looks like. But remember that we're going to first set up our proportion using lengths of corresponding sides, and then we're going to find cross products. And if the cross products are equal, the polygons are similar. So let's go ahead and take a look at example A. So here in example A, we need to determine if triangle ABC is or is not similar to triangle DEF. And we're going to use proportions in order to do that. So first thing we have to do is set up our proportion in order to figure that out. So we're going to have one side of our proportion over here, one side of our proportion over here, and then we need to figure out what we're going to do as far as sides go. So remember, we want to have corresponding sides. So on one triangle, the bottom of the triangle or the base of the triangle is 5. So I'm going to set that up as the top of one of my proportions. So then I need to have the top of the base of the other triangle to be the top of my other proportion. So the base of the second triangle is DE is going to be 6. Then it doesn't matter which side I pick. You could pick any sides as long as you're picking two of the same sides. So then I'm going to take the height of this triangle from A to C, and that's going to be 12. And then I'm going to take the height of the other triangle, which is D to F, and that's going to be 8. So now that I've got all of my sides together, I'm going to cross multiply to find cross products. So I'm going to do 5 times 8, that's going to give me 40, and 12 times 6 is going to give me 72. So is 40 equal to 72? No, it's not. So triangle ABC is not similar to triangle DEF because the cross products were not equal. So now let's see if we can make them equal in example B. So here in example B, we've got two parallelograms. LMNP is similar to parallelogram ABCD. And again, we're going to use proportions to figure out if they are or are not similar to each other. So we're going to start by drawing our two sides of our proportion. And then luckily for us, there's only two numbers on each parallelogram, so we don't have to pick and choose. We can pick the ones that are there. So we're going to start with the short side. So I'm going to start with the short side of 20 on the top over here, and the short side of AD 30 over here. Then I'm going to go for the long side, and that's going to be 34 on one of my parallelograms, and that's going to be 51 on my other parallelogram. So now that I have my proportion set up, I'm going to cross multiply. So I've got 20 times 51. So 20 times 51 is going to give me 1,020. And now I need to do the same thing to the other side. I need to do 34 times 30, and that's going to give me 1,020. So are they equal? Do I have cross products that are equal? Yes, they are. So parallelogram LMNP is similar to parallelogram ABCD because the cross products were equal. Now let's move on to example C to figure out how we find if one of the sides is missing using this method. So here we are at example C, and it says write a proportion and solve for x. So this time when we set up our proportion, we're not trying to determine if these are similar. We already know that they are. What we need to do is use that knowledge to solve for x. So we're going to start by setting up our proportion like we just had done in our last two problems, except this time when we select our sides, we're going to have to make sure that one of those sides has the x. So we're going to start with that one because we know we're going to need to pick that side. So the x is across the base of the triangle, so I know that's one of the sides I'm going to have to pick. So I'm also going to pick the base of the other triangle because, again, we need to make sure that we're picking the same sides. Then it doesn't matter whether you pick the height or the hypotenuse. I'm going to choose the height. So for the triangle that has the x, that's going to be D to F, and that's going to be 20. For the triangle that has from P to L, that's going to be 8. Now that I've set up my proportion, I'm going to solve just like I've solved proportions in the past. So I'm going to cross multiply. 8 times x is 8x. 6 times 20 is 120. Then I'm going to draw my wall to solve my equation. I'm going to divide both sides by 8 because the inverse of multiplication is division. 8 divided by 8 is 1, or 1x. 120 divided by 8 is 15, so my answer is 15. So notice I used what I knew about similar figures and proportions in order to find the missing side. Now let's take a look at example D. So here we are at example D, and it says which three proportions can be used to find the value of x. So the best way to do this is to make sure that you're going to label each side specifically and then match them up to see if we've got proportions down at the bottom. So I'm going to use colors. If you don't have colors, you could use shapes, but colors always make things a little more fun. So for me, I've got the height of this triangle is going to be x, so I'm going to label that in blue, and the height of the triangle is going to be 28 over here. Then I've got the bottom of my triangle is going to be 9, the bottom of my triangle is going to be 12, and then the far side of my triangle is going to be 20 and 15. So now that I've got everything labeled correctly, let's see if we can make some matching proportions. Again, if you don't have colors, you could use shapes. So for example, I could say this is a star, and this is a star, and this is a square, and this is a square, and this is a circle, and this is a circle. That will also work if you don't have colors, but again, colors always make things more fun. So let's start with our first proportion. So we've got 9, that's going to be a base or a bottom. 12, that's also going to be a bottom. X, that's going to be a blue one. 28, that's also going to be a blue one. So we've got 2 oranges, 2 blues, and they are across from each other. So that is perfect. That is a correct answer to our proportion. Now let's take a look at our second problem there. We've got X, that's going to be a blue. 20, which is going to be a pink. 15, which is going to be a pink. And 28, which is going to be a blue. And we can see that this proportion is not going to work out. How do we know that? Well, on our other proportion, we had 2 blues on the same side, 2 oranges on the same side. In this case, we've got blue and pink, they're not on the same side. Blue and pink, they're not on the same side, so that doesn't work. They could work horizontally, however, blue and pink, no, blue and pink, no. So since there's no matches anywhere, that is not a correct proportion. So let's take a look at our third one now. We've got X, which is going to be a blue. We've got 15, which is going to be a pink. We've got 28, which is going to be a blue, and 20, which is going to be a pink. So let's see, do we have some matches vertically? No, we don't. However, we do have matches horizontally, so this is a correct proportion. Now let's go to our next one. We've got 9, which is an orange. 12, which is an orange, X, which is a blue, and 15, which is a pink. We can see that this proportion is not going to work out because we have 3 different colors in here. Heck, 3 of the numbers come from the same triangle. So there's no way that this could be a correct proportion. Now let's take a look at the last one, and we've got X, which is going to be blue, our 28, which is going to be blue, our 9, which is going to be orange, 12, which is going to be orange, and then we can see that they match up horizontally in this case, so this is a correct proportion. Now again, if you don't want to sit around matching colors or symbols, there's no problem with that. You can simply just solve each proportion. Once you figured out a master proportion, figure out what X is going to be equal to, then you can check each one of the 5 proportions to see if it equals the answer that you got, and that will also give you the correct answer. It's a little more time consuming, but it will work mathematically if that's the way you want to go. Better safe than sorry. That brings us to the end of this video, so if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.